The nameplate momentary withstand ratings of disconnect switches and insulators are typically based on a three-phase half-cycle RMS fault current value. This value is used to determine the cantilever forces acting on the equipment during a fault. In the case of a single line-to-ground fault, often referred to as SLG fault, the fault current flows only through one phase of the equipment. This results in a higher peak fault current and a longer duration of the fault compared to a three-phase fault. The mechanical forces acting on substation equipment during a SLG fault can be significantly different from those during a three-phase fault. This difference arises due to several factors. Firstly, higher peak fault current. The peak fault current in an SLG fault can be up to 3 times higher than the peak fault current in a three-phase fault. Secondly, longer fault duration. The fault duration in a SLG fault can be up to 4 cycles, while the fault duration in a three-phase fault is typically limited to 1/2 cycle. Thirdly, asymmetrical currents. During a SLG fault, the fault current flows through one phase while the other two phases experience non-fault currents. This asymmetry creates additional electromagnetic forces on the equipment. To evaluate the mechanical forces on substation equipment during a SLG fault, the following steps can be taken. Firstly, determine the SLG fault current. Use power system analysis software or fault current calculations to determine the expected SLG fault current for the given substation configuration. Secondly, calculate the cantilever forces. Use the SLG fault current value to calculate the cantilever forces acting on the equipment using appropriate equations. Thirdly, compare to nameplate ratings. Compare the calculated cantilever forces to the nameplate momentary withstand ratings of the equipment. Fourthly, assess the adequacy. If the calculated forces exceed the nameplate ratings, additional measures may be necessary to mitigate the risk of equipment failure. If the calculated cantilever forces exceed the nameplate ratings, the following mitigation measures can be considered. Firstly, insulator upgrading. Replace existing insulators with higher-rated insulators. Secondly, switch reinforcement. Strengthen the disconnect switch using additional bracing or support structures. Thirdly, fault protection. Install faster-acting protective devices to limit the fault duration. Fourthly, current-limiting devices. Install devices such as current limiters or reactors to reduce the fault current magnitude. You can reference IEEE Standard C37.20-2018 IEEE Guide for the application of insulators on AC overhead lines. IEEE Standard C37.66-2019 IEEE Guide to Preferred Ratings for Power Circuit Breakers and Switchgear and EPRI Technical Report 3,000,2,006,005 Guidelines for assessing mechanical loading on substation equipment caused by single phase to ground faults.